What is nitrogen? Nitrogen, or N as it is known in science, is a colorless and odorless element. Nitrogen can be found in the soil beneath our feet, as well as the water we drink and the air we breathe. In fact, nitrogen is the most prevalent element in the Earth's atmosphere, accounting for almost 78% of the total. All living things, including humans, require nitrogen. Plants cannot survive if there is insufficient nitrogen, resulting in inadequate agricultural yields. Yet, too much nitrogen can be hazardous to plants. While nitrogen is required for our body supply, too much nitrogen can be harmful to the ecosystem.
Why is nitrogen essential? The delicate balance of substances that is important for maintaining life is an important area of research, and the balance of nitrogen is no exception. Plants that are deficient in nitrogen turn yellow, have stunted development, and produce smaller fruits and flowers. To boost crop growth, farmers might use nitrogen-based fertilizers on their crops. Scientists predict that without nitrogen fertilizers, we would lose up to one-third of the crops we rely on food and other sorts of agriculture. However, we must understand how much nitrogen is required for plant growth, as too much can pollute streams and harm aquatic life.
Nitrogen is an important component of DNA and other nucleic acids. Deoxyribonucleic acid, DNA, is a self-replicating substance found in almost all living species, as the major component of chromosomes and a carrier of genetic information, as well as RNA. Ribonucleic acid is a nucleic acid found in a living cells that works as a messenger for DNA. The most important of all biological molecules and essential for living things. The genetic information or instruction for how to build a life form is carried by DNA. Plants can create an amino acids if they don't get adequate nitrogen.
Stage 1: Nitrogen fixation. Nitrogen is transferred from this atmosphere to the soil during this stage. A large reservoir of nitrogen gas exists in Earth's atmosphere. However, because plants cannot use nitrogen in its gaseous form without undergoing a change, this nitrogen is unavailable to them. Nitrogen fixation is a process that converts N2 into a form that plants can utilize. Nitrogen in the atmosphere is converted into forms that plants can absorb through their root systems through a process called fixation.
Stage 2: Mineralization. This stage occurs in the soil. Nitrogen is transferred from organic elements like manure or plant matter to an inorganic form that plants can use. The plant's nutrients eventually run out, and it dies and decomposes. In the second step of nutrient cycle, this becomes crucial. When the bacteria interact with organic matter, such as animal dung or decomposing plants, they begin to convert it to a form of nitrogen that plants can utilize. Except from legumes and plants in cultivation acquire their nitrogen from the soil.
Stage 3: Nitrification. In soils, the third stage, nitrification, also takes place. The ammonia in the soils, which is created during mineralization, is transformed into nitrates, NO2, and nitrates, NO3. During nitrification, plants and animals that devour the plants can utilize nitrates. Ammonia can be converted to nitrates by microorganisms in the soil. Although plants and animals cannot directly use nitrate, other bacteria can convert nitrates into nitrates, which are used by plants and animals. This reaction gives the microorganisms involved in the process energy.
Stage 4: Immobilization. Immobilization is the fourth stage of nitrogen cycle. Together, this mechanism regulates the amount of nitrogen in soils. Microorganisms in the soil, like plants, require nitrogen as a source of energy. When the nitrogen in degrading plants remains is not enough, these soil bacteria extract nitrogen from the soil. When the bacteria consume ammonium and nitrate, these nitrogen compounds are no longer available in plants, resulting in nitrogen deficit. By binding up nitrogen in the soils, immobilization helps control and balance the quantity of nitrogen in soils.
Stage 5: Denitrification. In the fifth stage of the nitrogen cycle, nitrogen returns to the air as nitrates are converted to atmospheric nitrogen, N2, by bacteria through the process we call denitrification. This results in an overall loss of nitrogen from soils, as the gaseous form of nitrogen moves into the atmosphere, back where we began our story.
Ah, 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 ah. Este asunto es dedicado a toda esa gente que...